When people are learning C, one of the things that they find most confusing is pointers. In this video, I'm going to show you exactly what a pointer is, and we'll show you how to use them to make pass-by-reference parameters. For our first example, I just want to show you what a pointer looks like in memory. This code starts out by declaring an integer variable x and gives it the value 42. The next declaration declares a variable named y. Because there is an asterisk before the y, it is declaring y to be a pointer to an integer. Now, asterisk has two meanings. It could mean multiply in an expression, or it can make a variable be a pointer in a declaration. The fact that y is a pointer means that it stores an address as its value. In this example, y gets the value ampersand x. That means that we store in y the address of x. Ampersand means address of. Once we set y up to point at x, we can use it to change the value of x. In this statement, the asterisk means dereference or chase the pointer. So asterisk y gets the value 56 means that we put 56 into the location that y points at. Chase the pointer and put the value there. Notice that asterisk now has three meanings: multiply, declare a pointer, or dereference the pointer. Let's watch how that code works when the code is running. Let's just let it run until the variables are set up. In the Variables tab, you can see x has 42 and y is a pointer. See, that value is an address. And it even knows that the thing y points at contains a 42. Let's use the debugger to see what that looks like in memory. The register SP gives us the address of the top of the stack. We can dump memory from there to look at the local variables. If you don't understand what I'm doing, please watch the video on local variables linked on the screen and in the description. Here's the 42, so that's where x is. Remember, there are 4 addresses for each word, so the addresses of the columns end in 0, 4, 8, and C. So the address of x is FFFFCBE4. We can find where y is because that address will be stored in y. So in this assignment statement, the asterisk will make the compiler chase the FFFFCBE4 and will read and write where x is located. So when I step over it, you see that the value of x has changed, even though the assignment statement didn't have an x in it. And when we look in memory, you can see that it's changed there too. Now that was a pretty contrived example. Let's do another one that is a little bit more realistic. But first, we need to define some terms about parameter passing. Suppose I have a function that takes one integer parameter. When I call that function, I pass an integer variable into that function. In theory, there are two possibilities for how this works. The one we saw in the video about parameter passing is called pass by value. In pass by value, the code in the function can't change the value of the parameter passed into it. In other words, when func makes changes to x, the value of y is unaffected. It's called pass by value because only the value goes into the function. The function has no knowledge of the y that was passed into it. The other possibility is that when func changes the value of x, the value of y also changes. This is called pass by reference because we're going to have to give the function some information to let it reference the variable outside of the scope of the function. The short way of saying this is pass by value, the function can't change anything outside of its scope. But pass by reference means that changes to the variable within its scope affect variables outside of its scope. Or, pass by value are input-only parameters, while pass by reference parameters are input-output variables. In C, we use pointers to emulate pass by reference. As an example, suppose we're building a two-dimensional game. The player's position is stored as two integers, x and y. We want the player to be able to move north, south, east, or west. Each of those movements will change the value of either x or y by 1. So we want a function named move that takes the current x and y and a direction and modifies them appropriately for that move. Because we might change the value of either x or y, we can't return the new value. Instead, we'd like the function to be able to change the values of the variables passed into it. To do this in C, we're going to make the parameters be pointers to integers instead of just being integers. So the parameters to our function are a pointer to the x value, a pointer to the y value, and the direction we want to move. When we call the function, instead of passing in integer parameters, we're going to pass in the address of the x and y variables. When the function uses those variables to get to the value, they have to dereference the variable. That is, they have to chase the pointer to get to the value. But that also means that we can chase the pointer to change the value of the variable that was passed to it. So if we call it passing the address of my x into x, then when the function changes the value of asterisk x, the dereferenced x, it is actually changing the value of my x. We definitely need to go watch how this works in the debugger. I'll start by letting it run until right before it makes the call on the move function. At this point, we can see the values in my x and my y. When I click Step Into, it makes the function call, and we can see that x and y are pointers, and the values that they point at are 42 and 56. Let's look at what that looks like in memory. We can find my x and my y in their stack frame, and here are x and y in their stack frame. See how the address in y is the address of the location where my y is stored. If I step over to see one of the assignment statements work, we can see that it chases the pointer in y and changes the value in that location. That has the effect of changing the value of my y in main's stack frame, outside of the scope of the move function. The bottom line is that a variable that is a pointer contains a memory address of something else. We have two new meanings for the asterisk operator and a new ampersand operator to use with pointer variables. One place where we use pointers is to simulate pass-by-reference variables. To do this, we declare parameters to be the pointers and pass in the address of the argument. This gives the function the ability to dereference that pointer to change the value of the variable in the argument. In all of this, it's really important to be able to imagine exactly what the code is doing. Otherwise, you can get some bugs that are really hard to debug. So be careful about using pointers. And when you do, draw pictures of what's really happening to be sure you code it correctly.